Okay, guys, I'm looking at this continuity again, just real quick to see if I can clean it up for you a little bit, clarify. This continuity, you have to find discontinuity. And in this case, infinite discontinuity, it's going this way, it never touches. Jump discontinuity, it's from here to here. Now, this kind of thing would also show you that it would not be continuous, because if you're coming in from this side, you end up, whoops, if you're coming in from this side, from the left side, you're going to end up at 1. If you're coming in from the right side, you end up at 0. So because it ends up at two different places when it's approaching 0, that would not be continuous. Point discontinuity, it's only discontinuous right here at -1, because that means that the f of c does not exist. That's what we're getting to when we get to our rules here. The function is defined at c. Well, that point discontinuity that we had on the last graph, we've got x plus 1 on the bottom in a denominator. Your denominator can never equal 0, so that f of c, if x is approaching -1, it does not exist. So based on this first one here, f of c does not exist for that. That would not be continuous, and that would be your reason. Now, that's what you're doing at each time. Now, the other one that we had, the jump discontinuity, it was fine on f of c. What was not fine was it did not have the same y value on the left and the right sides. Back where we were, that's what I was showing you. If you are coming from the left to 0, if you're coming from the left, you end up at 1. If you're coming from the right, getting closer and closer to 0, approaching 0, you're ending up at 0. So they do not end up at the same point coming from the left and coming from the right, so it is not continuous. That is what each of those rules are talking about. You've got to decide if it's true, that if all three are true. And the y value that the function approaches from each side is the f of c, the same thing. Okay? So let's look at this one right here. I actually put it on a snap so that I could draw on it. Alright, so let's say that we want to see if it is, as x approaches 1. Okay, if it is continuous at 1. I need to take that down a little bit. Okay, so that is right here, 1, 4. That is the graph. I mean, that's the point. 1, I can see it. Okay. Is there any reason here that 1 would have to be thrown out, that f of c would not exist for this? And the answer is no. There's no denominator, there's no square root. It's perfectly fine for it to exist here. Okay? The next thing, does it approach the same thing from the left? Well, yeah, it's going to 4. As from the right? Yep, it's going to 4. So number 1 checks out, number 2 checks out, and then we're going to substitute it in f of 1, and you get 2, and that's 1 cubed, minus 3, it's hard to write with a mouse, times 1 squared plus 5. Okay, so 2 minus 3 is negative 1 plus 5 is 4. Exactly what we have right here. So 3 works. Okay, so the answer is yes, this is continuous at x equals 1, and those would be your reasons that you would put on your worksheet. So, hope that helps. That's all we